Shit. Oops. I said, okay. Now I really don't know if this is going. I might have to stop and restart this because. All right. Third time is a charm, as they say. And that indeed appears to be the case. So, once again, thank you for joining me this evening. Let's put this away. My name is Jordan Brandt. This is EVA Live, Electric Vehicles for All, nonprofit organization, newly formed and still in the process of being formed. But we have some large goals, and we're trying to get there as quickly as possible for the good of everybody and the planet. So, that being the case, I have created this channel and needed to create a platform to get this message out. And yes, as soon as possible. And also, I want people to be. So EVA is a grassroots organization, DIY, open source, crowdsource. I want people to be involved with not just the operations of EVA once it's up and going, but actually I want to bring people in and have people be a part of the creation of EVA. Now, we have established what you could say is the framework of what we do, and identified several areas where we will be focusing our attention first. And we would like to add more to that, though, and we'll be adding more to that. And that's where having viewers and people that listen to this as a podcast, having their feedback and opinion is valuable. So we encourage that, and thank you. And so let me just check one more time because I'm doing this solo, and looks like yeah, volume's okay. So with that being the case, I will try to proceed and with as little interruptions as possible. So I made a video last night that actually it was about 2 hours and 45 minutes, but it got cut off, or the live stream got interrupted about 40 minutes into it, and I've been working to get that back up, the whole video, so people can watch it. And then the idea is that with these long live streams, people can tune in if they want to get the latest information, or maybe they just listen to it while they're working. And but then what we'll do is we could take segments from that and put them into smaller clips and release those throughout the week. And in addition, though, this program, what you're seeing here, Eva Live, is just one of our shows, because it's a channel, right? So we'll have other videos and other programs that will cover other issues of sustainability, other areas, and excuse me, go into more detail on some of these technical projects. For example, being out in the field, or being in the shop and seeing some of these different repairs, whether it's troubleshooting or just different diagnostics and builds that we're doing. We have all kinds of build videos that we've been shooting footage of and getting that collected, and we'll be going through all of that and putting it together into these different videos, where some of those may be played on the show here, and then also released separately, or both. And so this show that you'll be seeing with just me tonight, this gives a general idea of what this show will be like. But yeah, it will be better as we progress and as we have more talent. So you'll see. Proof's in the pudding. So you'll see as we grow. All right. So what I was talking about yesterday or last night was, I was asking the question, are hybrids better than electric vehicles, or are they more important? And I guess I should specify it more important in terms of reducing climate change, greenhouse gases. That's what I have been researching and trying to get the answer to. And I'm not going to tell you that I have the answer for sure yet. I have what my opinion is at this point, and I have a lot of evidence that backs that up. Now, I don't do I don't do this for a living. This being crunching data. Well, I guess I kind of do that, but I'm not a professional. What's the word I'm looking for? Statistician. Excuse me. Yeah. So it's a lot of work. It takes a lot of time to make graphs and charts that with numbers too that reflect current things. And I guess I'm speaking very generally here, and I do make graphs and I will present them all the time. I'm just saying, a lot of times with this type of stuff, and especially climate change, like greenhouse gas models and emissions, I mean, it's very it's very complicated. So we have to simplify it, and in order to make it even fit onto a graph like this that a normal person could look at and maybe understand with some explanation, I consider myself to be a normal person. So that's what I will attempt to do my best to explain this stuff. And it's interesting, and it's important work. So I tied this together, this importance of climate change with fixing and repairing broken hybrid and electric vehicles, and which you wouldn't necessarily think that at first, right? But the two are linked, and it's actually, when you look at the amount of carbon we could reduce if we simply kept the hybrid and electric vehicles we have on the roads right now, ones that we already have, if we just kept those on the road for longer and took better care of them, right? If you do all the recommended services, at least the stuff that's important, then you can actually prolong the life of these vehicles. So, which basically means that every year you keep one of these vehicles on the road for another year, on a graph on these statistics that are showing the increase, the growth of hybrid and electric vehicles, then what we can do is we can change these graphs. We can make them go up faster. And so what you see here, and you know what? I forgot to add one other. Let me get rid of this. I have HDMI in. Sorry, I just realized there was you guys can't see. Let me get rid of this. My apologies. This again is live. So there. If I do that, I might really screw things up. So let me get rid of this. Hang on. Give me a minute here. Yeah, I'm supposed to have my HDMI in, but I can't get rid of one of these video sources. So get rid of this one, please. And I can't. All right. Let me try this. Excuse me. There is one thing I need to do. Again, this is live. This may screw everything up. No HDMI still. HDMI in. There it is. All right. Cool. It did work. Unplugged it and plugged it back in. Well, look at that. All right. Yep. There we go. Okie dokie, people. This is live TV. That's what you get. All right. Now you are seeing what is on my screen. So I have one that I drew on. So let me pull that one up. That is down here somewhere. Oh, now I just got to find that one. All right. Let me put these down. Here it is. All right. So what you have here, this is new policy scenario, and this is from a obviously a research article or research paper. This was the a large institution. What was this one? I could pull it up. It was, yes, World Resources Institute. No, that was not this one. That's a different one. Okay, but this one, anyways, one of these large organizations. And I will find that reference or that source for those who want it and put it in the link below. So, because it's not showing up on the bottom here. So, but what they're showing is these current, the new policies that are trying to increase electric vehicles on the road. So they have plug-in light-duty, I believe, vehicles, BEVs, PHEVs, light commercial vehicles, battery electric vehicle, and light commercial vehicle plug-in hybrid electric vehicle. So yeah, we have light duty and light duty plug-in light duty, and for consumer or you could just say the regular light duty passenger vehicles is what they're referring to, and then commercial vehicles, so trucks and everything that qualifies as that, and then buses, because those are state or municipality owned, right? So they're not considered commercial, although you could consider them commercial. And I guess here is a separate category for trucks. So, all right, and what they were showing was in this whole report, doing these different strategies to increase the number of electric vehicles on the road. They could go from this graph over here to this graph here, where, as you could see in all categories, it goes up faster. which is a good thing, right? Because I could show you corresponding graphs of when you make this go up, this being electric vehicles, you can make the, let's see, no, it wasn't that one. You can make the levels go down, greenhouse gas levels go down. That's the general idea. And so what I've drawn in here, and this is shooting from the hip. I'm just giving a general idea here. It could actually be more than this. And I drew in a line of if we did what Eva is talking about, which is keeping the ones we have on the road for longer, that we could go up faster and most importantly using less resources and yes, less time. So that's the general idea of what I wanted to show there. So people may ask, okay, well, what you're talking about, how is that different than what is currently available as used car dealerships and new car dealerships exist, and there's junkyards that already exist, right? So what are you talking about that changes that? Well, what we are doing is building a fleet of hybrid and electric vehicles, mostly like these ones here, like the Toyota Prius, that Voltec, the other company I own and manage, works on all makes and models of hybrid and electric vehicles. And so Eva is kind of just extending what Voltec has been doing for years, which is fixing these vehicles. But instead of fixing customers' vehicles, which we will still do that for people that own their own hybrid or an electric vehicle, they can bring it to us and we can fix it for them. But in addition to that, what we are doing is, yes, building our own fleet of these vehicles. And we get ones that are destined for the junkyard in a lot of cases, or they're high mileage and the body and interior may be in really good condition, but it needs a lot of mechanical work and a new battery, and it's just the cost to have other shops or dealerships do that makes any other person that would consider purchasing that vehicle from one of these auctions, it makes them not consider purchasing that vehicle, or they don't buy it, right? So where they go to then, the lowest bidder is the junkyards, and where they go to be dismantled, and the most valuable components are taken off, and the rest is pulled apart and scrapped. And yes, those materials will be recycled at some point downstream, but you have to keep in mind how much energy and resources it took to take those raw materials and put them together in that way to make whatever that component was of the vehicle. And when you hear people talk about Second Life for electric vehicles or hybrid vehicles, they will often be talking about the battery, right? That's the part that everybody just says, well, yes, the battery is the biggest, most expensive component of an electric vehicle. So let's focus on that, right? Which is not necessarily a bad idea. All we're saying is that there is a lot more there than just the battery. And another important thing to consider is that it's not necessarily the batteries that are important here, okay? What's important is that a working vehicle, right? One of these vehicles, it's the whole thing together, right? It's not the electric motor generators that make it efficient and make it what it is, right? It's not the battery that does that. It's all these things together, and all of them working together properly, and having it work efficiently at the levels that it's supposed to. Just going back to check. Okay, so Yes. So when people are usually talking about second life on electric vehicles, they talk about the batteries, and to the point where it used to drive me a little bit crazy because I'm like, how is everybody else missing this? Because um, yes, the battery is on electric vehicles, battery electric vehicles. It is usually, well, not usually, it is the most expensive single component of the vehicle, and usually the most resource intense component of the vehicle. Now, it requires resources and carbon to build any vehicle, regardless of what fuel it uses. And but for these electric vehicles, yes, the battery, and the larger the battery, then the obviously the higher the cost and the higher percentage that is of the what's called the manufacturing carbon footprint emissions. So reusing just the battery, right? You're missing a lot of the other stuff there. I would compare this to for those people that hunt. If you killed a deer and you just pulled out the heart, for example, and or whatever part, right, but left the rest of this meat, right? There's all this other stuff there on these vehicles. The battery is just one part of it, and actually, what's interesting is that when you get down to hybrids that have a smaller battery pack, smaller capacity battery pack, and they actually have a different chemistry usually. Most hybrids are using nickel metal hydride. So those are a power cell. So they are designed to take a large amount of amperage in or out, and for brief periods. So what you see here, one of these Gen 2 Toyota Prius, 2004 to 2009, you'll see them all over the place, right? That is a 1.2 kilowatt hour battery pack. So yes, you may say 1.2 kilowatt hours, that's it? Yes, that is it. And it really only uses about 800 watt hours from that because it keeps the battery between about 40 and 80% state of charge. And by doing that, the batteries can last a very long time. I've heard it called microcycling, I believe, or there's other terms for that. But yeah, so yeah, 1.2 kilowatt hours, right? So if you know anything about electric vehicles, you would know that well, if you start with a Chevy Volt, for example, that we'll say a Gen 1 that when it was brand new had a range of about 35 miles. And that battery pack, I believe, was 15 kilowatt hours, but it used about 12 and a half kilowatt hours. So again, for the same reasons I mentioned on the hybrids, except on this is a lithium battery, so it's able to go actually all the way from almost 100% state of charge down to, I'm not exactly sure what it does in the Volt, but probably down to 20% or maybe less. But yeah, it really depends on the battery chemistry and the manufacturer, and how much they're willing to go down. Just like internal combustion engines and vehicles and racing, you could take a Honda or something that's not very fast, and you can start modifying things on it, and you can get a lot more power out of that same little package. But there's a cost to that, and that cost is that it's not going to last as long, right? When you're running it at this higher output. The reason why they tuned it that way, it's not because the Honda engineers are boring. It's because they were trying to make a fuel efficient vehicle that would last for a very long time. Now, if you know about racing and drag racing or dragster racing, you know that they have to rebuild those engines. I believe, depending on what class it is, like, you might need they have a couple engines on hand, right? During the race, they might have to swap an engine and they have to rebuild them. And that's doing quarter mile runs, right? So, um, what I'm saying is that how you tune something or how much performance you want to take out of it, it's not necessarily limited by the performance of that component. It's well, how long do you want it to last, right? So you can get more performance out of it, but it's not going to last as long. And so you can fast charge, for example, but that's not, your battery is not going to last as long if you do that. It can't. It has a set number of charge discharge cycles. Well, I guess what's a window or a probability, right, of where it should be able to get. So for the Toyota hybrids, generally we see about 90% of them will make it to 200,000 miles. Now, again, that's a hybrid, so the way that battery is being used is very different than if we're talking about a battery electric vehicle. But yeah, there's a, depending on, and that there's graphs which, if I took more time to prepare, if I had more time to prepare, I could have one pulled up for you. But that show the more, right, the basically the more demand you're putting on a battery, like, if you're going all the way up to 100% state of charge and then all the way down to 10% state of charge and then you're fast charging it, right, you could show like it's going to have less life. It's not going to last as long. And depending on how deep down you cycle it, right, if you take it all the way down to 10% versus if you only discharge it down to 60%, well, that battery will last a lot longer. And so that's one of the key differences between a hybrid vehicle battery and an electric vehicle battery, is their usage is different, because the way I think about a hybrid vehicle, and when I'm talking about a hybrid, I'm talking about a strong hybrid or a full hybrid, like a Toyota Prius that can actually drive in pure electric mode or in gas mode or a combination of the two. And so that's what I'm talking about, unless I say otherwise, because there are other types of hybrids. So, okay, I guess let's just go through them. You have micro hybrids or stop start, which a lot of car makers include that now. It's really more about emissions, right? About idling, which it does help, that, especially in cities and places like LA. But it doesn't provide any electric traction or, move the vehicle necessarily. There are some that kind of do or give it a little push. But then we're going to go to the next category, which is, what is it? Medium hybrid, I believe, or a BAS, belt alternator starter. I think that's what it is. Yeah, belt. So yeah, those are a lot becoming much more popular now, and you'll see that offered as an option on a lot of vehicles, including full-size trucks, where like I know on the Dodge, it's like Dodge e-Torque. It's a 48 volt BAS system, and it has a big belt, toothed belt like you would see on a supercharger blower, and that's kind of how it sits too, is up on top. And I think they kind of did that on purpose, right? It does look pretty cool. And that has a lithium-ion battery pack, and that is a power pack, or more of a power cell of lithium. So that one is the latest, one of the latest chemistries, which we could probably talk about that more in the future here, once maybe we get our hands on one, right? If we can get one from the junkyard, and actually open it up and see what's in there, see what kind of cells they use, and I'm sure I could look it up too, but you know that uh, the whole reason I was talking about the differences though is because uh, I was saying the way I think about a hybrid um, is that it's a energy recovery device. Okay, it's more like a wind turbine than it is an electric vehicle, and it's a weird way to think about it. But well, what do I mean by that? So for a regular hybrid, so for a strong hybrid, yeah, there's medium hybrids, which I kind of skipped in there, but we're just gonna go to strong hybrids. Okay, yeah, there's a for strong hybrids, since they can go in electric only mode like that, and it's more than just that assist, like with a 48 volt system. Yeah, the way to think about it, well, yeah, they don't have there's no plug on the side of this on a regular hybrid, so not a plug-in hybrid, which would be the next step after a strong hybrid. You have plug-in hybrids, and actually you can convert a strong hybrid like a Toyota Prius. I know because the blue one in the picture there is mine, and the other one is my father's. And you can't see there's a bunch of other stuff on mine now that's not on it in that picture. But yes, it has been converted, and there's another video I made about that. It has what's called a high motion kit in it. There was several kits that were available that were being sold. They're no longer available at this point. But yeah, to convert your strong hybrid or full hybrid into a plug-in hybrid, similar to the Chevy Volt, but different, but can still achieve some pretty impressive results for considering what you're working with, right? But so if we back up to just not a plug-in hybrid, but a regular hybrid or anything below that, right? A mild hybrid, that those don't have any plugs on it. You don't plug it in. So how does it charge the battery? Well, it charges the battery sometimes using the ICE, the internal combustion engine. It's constantly monitoring the levels, and if it decides that it wants to charge the battery some, it'll charge the battery some, and that includes not just while it's idling, but also while you're driving along on the highway. It's flowing power back and forth, many times a second. Well, it could go back and forth in 1 second, right? But then the other way, that's just part of it. But the other way, primarily, is through regenerative braking, which you may have heard of, and so it's. Let me check one thing. Make sure. Okay. Oh, is it doing that thing? Oh. Oh, okay. Yeah, I can hear it. Sorry. Or wait. That is so weird. What about now? Ha, were you guys only hearing me out of one side? Because I just put in one earbud to start, and it was the left one, and there's a switch on the microphone to switch it to mono or stereo, and I somehow accidentally switched it to stereo. And I noticed it in the middle of what I was talking about there. So my apologies. Again, pardon our dust, and usually that's why people on live TV have producers and camera operators and whatnot. So, that's what you get. All right. Looks like that's working. So back to what I was saying, though. They charge their batteries by regenerative braking. And so the way I think about that is, all right, wind energy, right, is a form of renewable energy because it's there, right? it's the wind blows, and you can put up this device to capture that energy. Now, that's kinetic energy, right? You're talking about capturing kinetic energy and then converting it into electrical energy and then putting it into a battery where it's converted into chemical energy and then converted back to electrical, or however you decide to use that electricity. Or if it's like an old-fashioned windmill, it just turns something mechanically, right? It doesn't, maybe it pumps water or something. It doesn't have to make electricity. But that's mechanical energy that it's capturing. And we say it's renewable, well, because it's there, and we can just put this thing up and we can capture it, and you have free electricity at that point. So the way I think about it is, well, we have all these cars that are constantly driving around, and every time they put their foot on the brake pedal to slow down, to decelerate, that is kinetic energy that is being wasted as heat. In a normal vehicle, it's using brake pads or shoes to create friction to just slow the vehicle down, right? And that's just burning it off as heat. So you use gas to accelerate, and then you burn it off as heat when you decelerate. So a hybrid is just taking that and capturing that kinetic energy and changing it into electricity, and either using it, indirectly through its other accessory systems, which it is, but then it's temporarily storing that in the battery, right? And that might be as little as 1 second, right? Or that could be days or weeks, right? If you turn the vehicle off, well, whatever level it was at when you turn it off, that's mostly where it will be when you come back, depending on how long it is until you come back. But so what I'm getting at here, though, is that cars decelerating is a untapped energy source. You can't really call it a renewable energy source because these cars I'm talking about are using petroleum. So but it's an untapped source, so it's like, well, if it's already there, we might as well use it, right? So that's how I think, and I hope that explanation is good. I just thought of that like yesterday and been trying to develop it a little bit more. But yeah, hybrids are, and a hybrid battery is really more of a energy capturing device compared to a plug-in electric vehicle, a battery electric vehicle, which is a energy storage device and also releasing device, right? Because you charge it in the battery, and then when you drive it, you're releasing it through the electric motors and through the other accessories. But the batteries are different, and their requirements are different, and the chemistry is different, or sometimes similar. But the reason why I'm talking about that, why that's important, is because, well, like I said, that's cars slowing down it's just an untapped energy source that it's out there right now, for better or worse, right? And we can either use it or not. And a battery electric vehicle does the same thing, by the way. It does do regenerative braking, obviously, but it does not do idle charging. It just does plug-in charging, right? You plug it in, it charges, you drive it. Now, it has a further range because it can do regenerative braking, but obviously that doesn't mean the car can go forever, by the way, or that would defy the laws of physics. So, yeah, it's basically, though, it's an untapped energy source. And that's important because you'll hear the criticism of battery electric vehicles. Well, how are you going to get the power to charge it, right? Where does that come from? Which is a legitimate question, and it's often spun, though, in an illegitimate way or misleading way to suggest that Sorry, that it's fun. I lost track of what I was talking about because I got distracted again. All right, I wanted to check one thing. Make sure that our live stream is going. Just because, why not? I know I was leading up to a good point. See, I forgot. All right, good. It's working. All right. All right. Yeah, I was talking about. Yeah, it is a legitimate criticism. Just ask where does that power come from? But then they try to spin it when they say, well, it's you're getting all that electricity from dirty coal, and so that's actually worse. Well, no, it's not actually, and there's plenty of studies and graphs I could pull up that I've looked at and read that show beyond any doubt with real data that yeah, even if you charge with 100% coal-based electricity, it's still much cleaner than driving a regular internal combustion engine vehicle. And there's several reasons for that, but maybe one that I would say is the most important to consider is this: that when you have a power plant, right, even if it's burning coal, you have weight is not a concern. Weight and space, it's not, I'm not going to say it's not a concern, but it's not compared to a mobile application like a vehicle where weight and space is everything, right? Yeah, in a stationary application, you can have a huge emission control mechanism, apparatus, device. You can scrub the emissions clean and not have these, at least the more noxious gases coming out of there. Now, of course, the CO2 is still coming out, but even with all the power transmission losses and all the conversion losses, the efficiency still comes out above for the electric vehicle. Just because your typical internal combustion engine vehicle is about 20% efficiency in terms of for its thermal efficiency, and or I think that's the right one, right? Brake specific fuel consumption now. Anyways, maybe 25%, right? I know like a really large two-stroke turbo diesel engine, that the type that they use on like cargo ships and things like that. Those can have a 40% efficiency, thermal efficiency, if I'm recalling the term correctly. But yeah, so that's about as high as you can go with that. Now, hybrid vehicles take advantage of this thing called the Atkinson cycle, and which I won't go into the details of that. I'll just say it's Atkinson cycle. It's really it's late intake valve closing, LIVC, but effectively it's a simulated Atkinson cycle. We'll just say that. But the beauty of it is that it can also switch back to Otto cycle, which is just your regular internal combustion engine, like that. It's just changing the cam phasers that lets it, change that timing of the intake valve to make it later or earlier. And by doing that, by having a simulated Atkinson cycle, you have a internal combustion engine that does get closer to that 40%. I have to double check exactly what the thermal efficiency is for a Prius engine, but it's definitely more than the 20 or 25% that your standard car has. And but the issue with the Atkinson cycle is that it doesn't have good torque or hardly any torque at all from a low RPM. Okay, I guess that's kind of been changed with Toyota's truck. All right. I'd have to go to the tangent cam for that, but yeah, they've so yeah, when you make it better like that, I mean, okay, let me back up. I was supposed to start this other thing, which was to put talk to text on my monitor up here. so it will be writing, and I can see everything that I'm saying. It may not be totally legible, but at least then, when I start going off on tangents, I can connect back to where I was trying to go. But yeah, where I was, or if I back up, was I was on a total tangent about Atkinson cycle and thermal efficiencies and all this stuff. So I mean, because it's all these things together that add up to make a hybrid that gets 50 miles per gallon. I guess that's really the broader point of where I was trying to go, is that when you put all these things together, regenerative braking, Atkinson cycle, aerodynamics, which is why so many hybrid and electric vehicles are ugly, right? It's when you put all these things together that then you get a vehicle that can get 50 miles per gallon. It's not just you put a battery in an electric motor and voila, you instantly have a vehicle that'll get 50 miles per gallon. There's a lot more to it than that. And the thing about regular hybrids is that they do not require any, they don't have a plug, right? So they're just using, petroleum, gasoline, which is emitting carbon, but there is still carbon being released, but it's less than if it was a non-hybrid vehicle. And so the question really is, what has a larger impact on emissions? Well, you could have a mix of hybrid and plug-in hybrids and battery, which is indeed what we have right now and will continue to have. But what I'm trying to figure out is, what makes the most sense to get emissions down at now in the near term, because climate scientists agree that at this point we have less than 10 years to significantly reduce our emissions, or else we may have they say we will reach these irreversible tipping points. And as the name suggests, once you get there, it's hard to go back the other way. And so we want to avoid that. And if we can get there faster using less resources, well, how would you do that? Well, to increase these numbers, what you see here, the number of these electric vehicles on the road, means you have to build an increasing number of them per year. And then on top of that, you're losing a certain number of them per year. And I was explaining this yesterday, it might have got cut off, but when you're trying to increase the percentage of hybrid and electric vehicles on the road, well, you have to consider that 10% of all the vehicles on the roads in 2020 is a lot less than 10% of all the vehicles on the roads by 2030. So just to maintain the percentage that we're at right now, which is about 3.5% or 4%, requires building every year. You have to not only build the same number you did last year, but more, and just to keep it at that number, because you're losing a certain number per year, and from accidents and fires, floods, or mechanical damage, or what I was talking about yesterday, it being financially totaled, where the vehicle is salvageable, it's repairable, but the cost to do so, it's more than the vehicle is worth in the market value. So that's financially totaled at that point. And those are the ones that I really focused on, or that's what really caught my eye with all of this originally, was that, well, if we were to save those ones, right, we could make these numbers go up faster. And the thing is that all these vehicles I'm talking about, they're already all here. They've already all been produced, right? We're not waiting on shipments for these. They're here. And a lot of them are already in the junkyard or will be soon. And in a lot of those ones that have been sitting in junkyards, well, junkyards, despite what people may think, they are a business and they don't leave junk laying around. Uh, yeah, that seems to go against itself, but it doesn't, right? They're not going to just hold on to things. Well, at least decent junkyards, ones that are actually doing business and selling a lot of stuff, they're not going to hold on to stuff forever. If nobody, if they've had a Gen 1 Prius sitting in there and it's been 8 years since anybody even inquired about a part from that car, one day they're going to be going by and they're going to be like, man, we need some more space. Get rid of that thing. That's it. Look, when was the last time we sold something from that? Get it out of here, So, and even a Gen 1 Prius, there is, without the battery in it, well, there's still a lot of other usable components in there that are, special and unique to hybrid and electric vehicles that, in that case, if we said we're not even going to keep this car on the road anymore because, well, it's not possible. It's been, no battery in this one anymore, and it's been, sitting in this junkyard. There's no title for it, so there's no way to get that back on the road, at least legally, right? But these other components, so specifically like the inverter, the motor controller, the DC-DC converter, those are just two components, but you could even take more individual components like the IGBT transistors from the power inverter. Those are called the power electronics, and so that's an area where the Second Life hasn't been too focused. People that are looking at doing Second Life, it's mainly about the batteries, right? And then if they go beyond that, it's with the motors, and that's about as far as I've seen anybody else really talk about. And if they go any further than the motors, it would be to the inverters, like what I just said. But then beyond that, there's, you got chargers on board. If it's a battery electric vehicle, you got all types of, water pumps and coolant pumps and fans and switches and all kinds of things that, as it turns out, is the exact stuff you would need if you wanted to build a solar power system or a wind power system or micro hydro power system. Here you have motor generators, right? You have the power inverters or the components that you could actually build your own if you wanted to, like using the most expensive parts though, right? That if you wanted to build your own and you were buying these parts new, it's expensive, right? And for this grade, OEM grade, it's very tough and reliable. So it's a great way to afford to build one of these projects. And something like that is carbon negative because it is taking this renewable energy source it's there for the taking. All you have to do is collect it and use it, right? So yeah, that's one area of when it's no longer practical to keep that vehicle on the road, we could use those components. And well, that's great, right? But what does that have to do with EVA and all of this? Well, there's emissions to manufacture vehicles as well, all vehicles, and which means that building solar panels and electric vehicles, actually you release a lot of carbon to do that, right? And we have less than 10 years to drastically cut carbon. So we need to be really careful. We wouldn't want to be building tons of electric vehicles that are maybe junk ones, like that bad ones that just the design was bad or something. Which, guess what? How many startup companies can you name? I could name, man, I'm not even going to try right now, but there's a lot of new startup companies making electric vehicles, which is great. And I'm excited about that, and I fully support it. The only issue is, here's a big one that comes to mind, and you know what? It just so happens I have an article that was already pulled up about that, about Dyson's electric vehicles, right? Here, we'll switch you to here. You guys could see what I'm seeing and hopefully not hear that. Maybe you are. Let's see, are you hearing that? Is there audio there? No audio. Okay, good. All right. Anyways, well, yeah, here you have Dyson, who makes vacuum cleaners and cordless vacuum cleaners. And they announced a few years ago they were, going to make an electric vehicle. And I believe they spent about, or got investors and have spent about $2.5 billion on this project. And they never, they built some prototypes, but they didn't, I don't think they actually manufactured any in any quantity. So, well, that's good. And what I mean by good is that if they had made a bunch of these things and let's just say they made a bunch of prototypes and then they said, you know what, this is just not working, get rid of it and scrap all the prototypes. Well, that would be a bad thing. And even if they did that, okay, this is actually kind of the perfect example of where how EVA can reduce these emissions that it take the carbon footprint to build these vehicles, right? We can reduce that, which just means that the lower that is, the less time it takes for that vehicle to pay off its carbon debt, and the less time it takes it to do that means the sooner it's carbon negative. The sooner it's carbon negative, the better a chance we have of not hitting those tipping points. So in a case like this, like with Dyson, they spent $2.5 billion, right? That's a lot of money. And granted, I don't know how much of that was on materials and how much of that was, labor and different costs like that. But even the labor costs, all right, you could look at the carbon footprint of anything you do, brushing your teeth, right? You're using water. I mean, it took energy and resources to make the toothpaste. It took energy and resources to make the toothbrush. And how many times did you use that toothbrush before you threw it out, right? Like, you can actually break this stuff down to be that detailed. And so even their engineers, right? You're paying engineers and they're spending hours working on this. The food that they're eating, right? I mean, some of them are a vegetarian, right? And then maybe some of them are not vegetarian. The ones that are not vegetarians have a much higher carbon footprint. I mean, I know that's funny, and yeah, it's funny, but it's true, right? I mean, doing any of this stuff, like when you're spending money, you're deciding how that this really, money is energy and energy is money. To just go right down to the root of things, that really is the truth. So when you're spending money, you're spending resources. You're using resources to some effect or another. And whether that's by literally mining materials or if you're spending it on labor. So yeah, that's in this case though, $2.5 billion, right, of resources was consumed. And there isn't really anything to show for it, right? Now, I'm sure they learned a heck of a lot about this. And hopefully some of what they've learned can be shared, or, I know they made all kinds of patents. Now, whether or not those are actually good or useful, I don't know. But, yeah, maybe they can, some of the benefits from this maybe can go towards to help the rest of the industry, right? That would be what I hope for. And it may not, right? I mean, it might just be this was like a business experiment for them that they tried and it failed, and that's that, right? Which would mean though that $2.5 billion of resources was effectively wasted during what you could argue was really the most important 10 years in human history as far as using resources. And So it's kind of like triage, if you know about triage. It's triage came from it's a French word, I believe, that during war, when they were on the battlefield, the medical people were trying to figure out when injured soldiers are coming in, who gets care first. And when you only have, in this case, being out in the field in a war zone, right, with limited supplies and limited medicine, limited bandages, the job of triage was to determine basically who was going to get care and who they were going to let die, basically. As bad as that sounds, but that's just the grim reality of it, and that's why, war is a terrible thing that we should oppose. And but that's, if you think about that, though, they're deciding, okay, we only have so many resources. I have this many bandages. I have 2 surgeons, right? And the surgeons can only do so much work. I mean, they can't do 2 amputations at the same time, right? They can't tie 2 arteries at the same time, right? They have to say, okay, here's the resources we have, and we're going to use that the best we can to treat as many people as we can. And if you have a certain amount of blood, right, which I guess I'll say in this analogy is like the lithium, or just the rare earth materials, right? So that's like the precious. That you have a set amount of it, right? That's that they had, and it doesn't make a lot of sense. And again, I'm not going to say hypothetical. This is real. This is what really happens in war, and this is what really happens with triage. Is if a certain group of soldiers were injured by a bomb or something, and the triage is supposed to, as these soldiers come in or as they're going to these soldiers in the field, to look and see basically who they can save or who is worth saving. And what I mean by that is, well, if you only have so much blood and this person has lost, just had both their legs blown off, well, you could, if you gave all the blood you had, you could save their life. But the amount of blood it's going to take to save their life, you might be able to save 10 or 20 other lives. So that's the job of triage, right? And that's a tough call. But when you look at it like that, I guess it's not such a tough call when you dehumanize it, at least, which is necessary in that kind of situation. And again, which is why we should oppose war. But so that's where triage comes from. And so when I'm talking about this, just like the blood and for the soldiers, well, lithium is the blood of our hybrid and electric vehicles. Rare earth materials, because it's not just limited to lithium. And that may change, by the way. I mean, we have, who knows? There could be there's some really exciting battery technology research that's going on that I follow or try to keep up on, because it's literally every day changing. But you got sodium-based batteries, and of course, sodium is very plentiful. That's what's in the oceans. Sodium chloride. They're ionized, so they actually are separate at that point. Chemistry. So lithium, rare earth materials. That is to electric vehicles what blood is to the soldier in the field, or to any human for that matter. It's precious, right? And you only have so much of it. There's only so many blood donors, people that choose to give blood. And of those, there's certain types, right? And that you have to match with specific types. And so how you use that is real important. And so, again, does it make sense to use the amount of that precious resource to make one vehicle when perhaps you could have made 10 other ones that had the same carbon reduction. Well, each one of them. You could have more carbon reduction with more of these other ones. And so if you had a BEV, battery electric vehicle, that goes 400 miles compared to 4 BEVs that can go 100 miles, which of those two scenarios would have a larger impact on carbon? And the answer would be the 4 with the smaller battery pack. Now, I've omitted there all the other carbon footprints of making all the motor generators and everything else for those other 4 cars. And that was just based on the battery. But what is it that is bottlenecking the manufacturing of hybrid and electric vehicles? Rare earth materials, right? I mean, that and manufacturing capacity and several other things, but that's a big part of it. So, yeah, that's an area where we should be doing a bit of triage. We should be saying, okay, and actually not just for the rare earth materials. I'm talking now about all carbon, really, and really in the next 10 years here. We should be saying, okay, you want to do this? Well, we need to look at this whole project, and does that make sense, or what do we think makes the most sense, which is going to change with time. And I'm not suggesting that we should police what people can make. No, not at all. Companies should be able to make, and I would encourage them to make new electric vehicles. What we don't want to see, though, happen is a lot of this. But what I could tell you, though, is that unfortunately, we have indeed been seeing that, and that's not a new thing. If you've been following this industry for a while, it's the road to electrification is littered with many different companies that failed, right? And there was the whole thing with the Fisker Karma, but they're back now. But that whole thing. And there's many others, and many not even just new companies, but models that a manufacturer made and then discontinued, right? Because a lot of those, they were just kind of trying to figure things out and get some data from it, and they needed to look like they were doing something, right? So they kind of dipped their toes in it to do something and learn something too. But yeah, so Dyson, $2.5 billion, at least from the article I was reading the other day. That's kind of a funny picture, right? And you get all this stuff stuck in your vacuum cleaner. Although the Dyson vacuum cleaners are supposed to not get clogged. I don't own one, so I can't say for sure. But I think it's kind of metaphorical too. Like, it's like all these little things, right? Dragging this car down, or it's not necessarily like the obvious things you would think of, right? It's like the lint in the carpet that's getting caught in the wheels and slowing this thing down. Yeah, right there. Said he had planned to spend $2.5 billion, and they might have even got more than that. This term, vaporware, look that one up. I won't explain that, but I can attest, having been in this industry now for a while, seeing that quite a bit. I'm sorry, I'm hitting my vaporizer a few times. I needed some nicotine because it's like 1 a.m. If I just keep going live on air for hours, I'll get somebody's attention, right? Eventually, something. Yeah, you guys are supposed to be reading this here, not me. What? You thought I'm going to do all the work? I told you this is a team effort. Whoa, whoa, whoa. Okay, go back up. I was going to highlight this. 12,000 employees and billions to wager without fear of impatient shareholders or investors. Okay. Yeah, they were going to make this electric SUV for 40 grand. All right. Wow, this article's long. I was just trying to find how much money total because the last the last I had read, it was about $2.5 billion that was spent on this project, right? So, um, the question is, how much of that was material, and how much of those prototypes were thrown out, or even if they were recycled? Well, that's a significant amount of carbon that was released in that entire process to make something and then break it back down into the materials again and then make it into something again. It's a lot of energy. So I am not discouraging the development of electric vehicles. I have a solution for this problem. EVA has a solution for this problem, and that is that there's a lot of this stuff that we could have put to use, right? Maybe they still have it. Maybe they can hear about this video and somebody can tell them, hey, you can donate that stuff to EVA. And EVA may be able to give you a tax credit or something for it. Maybe, maybe not. And but either way, what they're going to do with it is they're going to find uses for it. And then they're going to make that available to people that want to use it. And we're not talking about just, I don't know, maybe you've seen things where people take like a old toilet bowl or something and make like a planter out of it and grow sunflowers out of it. It's funny and it's cool. And it is reusing something, right, that would have otherwise been thrown away. But, it's not very utilitarian, right? In other words, it's not. Art does have a purpose. I'm not saying that, but it's not driving anybody around, right? It's not generating electricity from photons. So, but what I'm talking about is specifically taking these materials that are byproducts or waste of electric vehicles. So not just the vehicles themselves, but actually all that research and development and prototyping that they had to do, right? Just to get to a vehicle. There is a lot of material. It's a very resource intense activity. To research and develop and make prototypes and then smash those prototypes, right? To burn those prototypes, to freeze those prototypes, to drop them into pools of water, you name it. They have to try everything to it, and there may or may not be something usable at the end of that. Now, of course, there's also, when you're talking about prototypes, well, obviously companies, they're not going to just want to give those away, right? They don't want people to know what their latest stuff is. But, there's solutions to that. Like when I was saying, well, you could at least pull out the components or allow us to disassemble and remove down to just the component levels themselves that are, components that are available. A lot of these components they use on electric vehicles are actually the same. They come from the same suppliers. So you may have different makes and models using the same electrical connectors or the same battery cells, all right? LG battery cells or a whole battery pack that's been made by LG, which is the direction we're moving with things. That is that the automakers are especially with electric vehicles, they are not doing it all in-house. A lot of the components are being done by other companies, right? I mean, they need a company that makes battery cells, and then in the case of LG and other companies, they're starting to say, well, here's a battery pack that you could configure for your vehicle, and we have different options, and so they don't even have to design a battery pack anymore. They're just gonna purchase this one from LG, and LG will dial it into their application, and so that that means that it's not all being done in house at the automakers, but the suppliers are doing that, and you have the same thing with the suppliers. There's a lot of materials there that need to be scrapped and need to be recycled, but EVA is presenting an alternative, which is to donate that material to EVA, and we will find an application for it. And it could be something as basic as a switch, like a window switch, or something like that, right? Or something as complicated as a whole transmission or transaxle assembly with the motor generator incorporated inside of it. Anything on that scale, because reusing those in these other projects, it's not just good from a carbon perspective, but it's cheaper, right? And if you guys have ever tried to set up your own solar system or anything like that, or considered it and started shopping around, reading about it, one thing you're going to learn real quick is it's not cheap, especially if you're trying to be off the grid completely and have your own battery backup system, and it's not cheap, and but it is a heck of a lot cheaper if you could. Now, not for the whole system. It's not possible necessarily to have the entire system built from refurbished or used parts from hybrid and electric vehicles, but it is possible to have most of the system, or at least some of the main components of the system, using those parts. And, even if it's only 10% of the total system, but you're able to bring the cost of that down 10%, or in some cases, you might be able to make, let's just say a solar system that was going to cost $10,000, right, for a certain performance with the battery bank and the inverter and everything. And it was $10,000 and it had 10 kilowatts, all right? Well, it might be possible using parts from EVA and things that we've already tested and already assembled as well. You could maybe cut that price in half. Maybe you could cut it in a quarter, right? And well, okay, saving money is great, Jordan, but, what does that have to do with the environment? Well, everything, because if it's a quarter of the price, that effectively means that you could deploy 4 times as much solar panels, right? So if you make it cheaper, you can do more of it. And if we do more of it, the more carbon savings we get. And the sooner we do that, the more important. And actually, you could argue that doing things that don't really have any or much of an effect until several years down the road, or 10 years down the road, you could argue that that would be futile, or perhaps working against our own interests, right? But we have to get energy from somewhere, and we can't just flip a switch and tomorrow be carbon neutral. And there is a path to get there. And that path will use and consume resources. And how much, and how much of a mess it makes, that is to be determined, right? And EVA is proposing and has these methods to make that process cleaner and have less waste. And even though if you have waste or byproducts, if you can use that for something else, and if that something else is a carbon negative application, That's the big point here. Okay, if that is a carbon negative application, you are then offsetting that manufacturing. In the same way that if you build a solar panel, yes, it took a certain amount of carbon and resources to build it, but after a certain number of hours or a certain number of kilowatts, really, of generating solar electricity, it has repaid that carbon debt, and every kilowatt past that is called carbon negative. And so, to recap from yesterday, there's two ways, basically, of reducing carbon in the atmosphere, and that is literally pulling CO2 from the air, whether that's by planting trees or algae or machines that just literally pull it from the air, or by improving the efficiency and reducing waste of systems and processes that already exist and are already happening, that release carbon. So they're things that already are releasing carbon, but if you can make those more efficient and make it so they release less carbon, the net result from both of those is the same. There's less carbon going into the atmosphere and into the oceans. That's basically the better option is, and specifically for Dyson here, they have, who knows, over $1 billion worth of materials and prototypes, and that they could recycle, scrap or recycle, or they could donate it to EVA, and we would find a use for it. And it could be as basic as things like copper wiring. I mean, maybe you don't know, but copper wiring is actually kind of expensive. If you're trying to buy hundreds of feet of it, yeah, it's expensive. And also worth mentioning, all of these components in these vehicles, it's all OEM grade, so it's all the highest quality grade, basically. I mean, it's underneath, aerospace grade, but it's not. It's made to be in a really harsh environment, probably one of the harshest environments you could think of besides space, or the bottom of the ocean, or the sun, Mercury. But it's designed for this really harsh environment, and it's designed to be extremely reliable and extremely redundant, and just, it has to work. It can't break, right? Now, of course, things break, but that's what they're going for with OEM grade. And not all materials used in electric vehicles, or all vehicles for that matter, are considered OEM grade. And a big one specifically would be cylindrical batteries, lithium cylindrical batteries. They're really not considered to be an OEM grade. Why? Because these were designed for laptops, right? They weren't designed for cars originally. Doesn't mean you can't use them, right? Obviously you can. Many companies are, and Tesla has thousands and thousands of them, over 8,000 of them, and this is a 26650, so it's larger. There's 18650 over there, but y'all are familiar with that anyways. But yeah, so these components, even if you're just talking about it like a window switch or something, I mean, it's gonna be it was a switch that was designed to last a long time, to be used very, very frequently, designed to have hot coffee spilled on it, designed to be slammed, punched, right? I mean, it's not necessarily going to survive any of those things, but that is the aim when they're talking about OEM grade. It's those types of things. They have to put it through every single abuse test they can think of, because whatever they can think of, somebody will do. You just think of whatever the stupidest idea you can think of, somebody will do it. So, you're going 70 miles an hour on the freeway, let's put it in park, right? Why not? Good news, you try that on one of these cars, it just goes beep, beep, you're an idiot. I'm not doing that, right? Side note, though, it will let you do it if you're going about 3 miles an hour, which 3 miles an hour doesn't seem like much until you're in a vehicle and it comes to a abrupt stop. If you've ever been on a boat and been in a type of collision, or they just came up to the dock too fast, right? It came up on the shore. The thing was only going, yeah, maybe 1, 2, or 3 miles an hour, and you're sitting there, holding a beer or something, and you're not paying attention. And all of a sudden it just stops abruptly. I mean, all this stuff goes flying, everybody falls over, drinks spilling, right? Chaos. A 3 mile an hour collision can do that. So, yeah, they got to test for all these things. And so if you're building some type of renewable energy system, or maybe it's not even a carbon negative application, but maybe you're a high school teacher and you're building with your technology class students, you're building a drone, right? Or a robot, like a battle bot or something, right? You're going to need all these types of things I'm talking about: electrical connectors, wiring, different microcontrollers, switches, just all kinds of things. And the power electronics stuff I was talking about. And then, of course, batteries, motors, pumps, coolant pumps, fans, displays. I mean, it's like pretty much anything you could think of, we could do. Now, with what's possible nowadays with open source technology, Arduino, MicroPi, it's really exciting. And we still are working on projects like that where we have videos of it, and actually I could maybe pull one up for us tonight, but just of using these open source controllers to hack, repurpose electric vehicle components. So we have a video where we have a motor from a Coda electric vehicle, which is one of those ones that most of you probably never heard of, but go ahead and look it up. CODA, and yeah, there's a whole story on that, and Luke, when he's here, could really fill you guys in better on that whole story. Being as of today, he owns 4 Codas now, so yeah, it's a obscure electric vehicle that's not in production anymore. That was, well, it was in production, and there were some made, but they're just, well, yeah, look it up if you're interested. But yeah, we have a motor from one of those, and it's motor controller, the inverter converter assembly, on a benchtop setup, and a battery from a GM 2-mode hybrid, which is actually a nickel metal hydride battery pack assembly, using the same battery modules as the Toyota hybrids. And we have all this on a benchtop setup, and we got a brake pedal and accelerator pedal there and a couple switches, and we were able to control this thing and drive it, spin it, put it into reverse, go backwards, program in how much torque we want, set torque limits. It's really cool stuff, right? And that is ready. Where we have that thing on the bench, it's ready to go into any vehicle you want, anything, whether it's a boat or a car or anything. Maybe it's a wood splitter. I don't know. Use your imagination. Anything. It's ready to go. It goes in there. You push this thing and it spins this way. You pull this lever, spins the other way. I mean, it's that basic. If you want it to be that basic. Now, we can also make it as complicated as you want. The sky's the limit as far as features and things that you want to do. And just like how I have a live broadcasting television studio from my house now in 2019, right? And single-handedly doing this broadcast and all this stuff myself, and assuming that the signals are getting through to you, then it's pretty incredible, right? And we're using this platform to teach and learn from each other. and share our knowledge, which that's exactly what I'm doing with Eva. And we are sharing our knowledge that we've learned the hard way through blood, sweat, and tears, spending lots of money. And what do I mean by that? Well, when you make a mistake and when you have a company that you fix people's hybrid electric vehicles, if you make a mistake, then you have to fix that, right? And so it could be a $10 mistake or it could be a $2,000 mistake. So, it's where was I? What was the point of all that? Well, it's expensive, and that's about it. And there was something else, but I didn't set up my recorder thing so I could keep track of all my tangents. At this point, it's just tangent, 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 tangent. I don't think I've actually completed anything. So I just almost get to the end of one thought, and then I'm like, nope, going to the next tangent. Inception. It's like Inception, going deeper and deeper. But all right, back to Dyson. Which, yeah, I was building up to some point there, and then I lost it. That's why they have co-hosts, by the way. But, yeah. I think that makes sense to me, because I used to ask myself, why do they even have co-hosts? Like, it seems kind of redundant, right? I was talking about components. Yeah, maybe you're a science teacher and you're building a drone for your class. You should use used hybrid electric vehicle components because they're going to be better quality than you could get buying anything off the shelves, and it's going to be a fraction of the price of whatever you get off the shelves. And now you also might be saying, well, wait a second. There isn't anything really of value still in a 2001 Toyota Prius, right? Well, actually there is. And I'm saying excluding the battery. Like, I'm not even talking about the battery right now. And actually, if there's anything that's not very useful from a 2001 Prius at this point, it would be the battery, except for one that I had come into my shop earlier this year. It was a 2003, but it was a Gen 1, and it had, what was that one at? 350,000 miles, and it was on the original hybrid battery and the original 12-volt AGM lead-acid battery. I've never seen any other lead-acid battery go, what is that, from 03 to 19, 16 years. Wow, that's impressive. And now, its capacity wasn't great, but I balanced the hybrid battery and we had that working. There was another issue though, which was the vehicle needed a transmission, which I was advising them against spending all that money on that. I was recommending they should maybe part with that Gen 1 and get into one of these Gen 2s. And which you may say, well, then you're contradicting yourself. Well, we have to draw a line somewhere as to what... See, because I didn't say keep as many on the road as possible. I said keep as many on the road as is practical. Because not all of them are necessarily worth keeping on the road. But even that Gen 1, the only reason why I was advising them against that was just because of the amount of money and the risk that they would be taking doing that. And I would be ill-advising them if I told them not to do that. Now, this is probably a good time to point out, I don't know what your relationship is with your mechanic, but has your mechanic ever actively dissuaded you from doing a job that cost over $1,000 in labor, meaning that shop would be getting over $1,000 in labor? Probably not, right? And it's not because I can't do that or don't want to, but like I said, it's a lot of other factors involved. I told them, hey, Well, you're at 350K, so even though your hybrid battery is still working, it's going to need to be rebuilt. I cannot rebuild it with Gen 1 modules because I don't have those in stock anymore. The only option is to replace all of them with Gen 2 modules, and there is 38 of them in a Gen 1 pack compared to 28 in a Gen 2. So that's significant. And then on top of all of that, you got, suspension. That's, original struts on there. It's like you guys might be biting off more than you could chew here. And it's like if you're going to do all this work and you're going to put a component in that's going to get another 100,000 or 200,000 miles, well, you got to ask the question, what about everything else? And are you prepared to fix that other stuff? Now, if you're a consumer, the answer is probably no, because you have to pay a shop like Voltec, if you're lucky enough to find a shop like Voltec, to do that work. Otherwise, it would be to a dealership, which, yeah, good luck with that and the price on all that. They don't use refurbished parts. They don't use used parts. So, yeah, that would be your options would be limited if you had a vehicle like that. Which is why I advise them not to do that. But however, under EVA's system, even a vehicle like that, we actually might still keep on the roads for a while, depending on what it needs, right? Because since we are a fleet, since we own a fleet of these vehicles, that means, and since we only work on specific vehicles, just hybrid and electric, and only specific models that we have in our fleet, well, that makes a lot of things work better and easier. So we can have other vehicles that we buy of those same models that were in a bad accident or something where you can't put that vehicle back on the road, but you can use it as a donor. Think of it like organ donors. If somebody is an organ donor, which I am, and I recommend you be as well, does not mean that they are not going to try to save your life as much. I believe it's probably the opposite. Medical workers, I would have to think, would maybe respect the fact that you're an organ donor, would maybe try a little bit harder to save your life. Definitely not try less. Tangent cam, that's what the tangent cam's for. But yeah, think of them like an organ donor. So, when somebody dies, it could be somebody that was at the end of their life, and not to sound crude or shallow here, but their parts that are left are a bit worn out, right? Now, but there's still usable stuff there. And gosh, I hope I don't sound like a monster, but this is real. I mean, organ donation is a real thing. So I'm going to talk about it in literal terms. But you also might have somebody that was younger that died from an unnatural cause. And unfortunately, that's something that does happen all the time. And it's, in that case, well, there is a lot more good that can be done with that. And, the fact that from somebody's death, they can actually save other people's lives, that's a good reason, right? I mean, that's enough of a reason for me. And also, I'm not going to be here anymore. Why do I need my lungs anymore if I'm dead? I don't. So you can have them. It's the same deal, just like with my cars. But yeah, there would be some more things that could be used there to save other people's lives. And it's the same is true with these vehicles. You could think about it in that same way, that when one of these vehicles dies or is taken off the road, and it can't be put back on, all the king and king's men can't put it back together again, that's when it becomes a donor, right? Because just because it wasn't an accident, there's still going to be lots of other parts on that car that you could use. And just because it was in a fire, there might still be a lot of stuff you could use. And you might be saying, whoa, you're crazy. That's unsafe, right? To use parts from a vehicle that was in an accident. Well, that's why we test them and make sure that everything is working properly and within spec. And you may have grew up hearing the rumor that once a car's in an accident, you just can't ever really get it right. It's never going to be right. Well, what that was crappy mechanics that just never fixed it right, or cheap customers that never paid the mechanic to actually fix everything that they said needed to be fixed. Yeah, every car can be fixed. I'm not going to say there's no such thing as like a cursed car, because I've ran into a few that really did just seem to have some kind of curse on them. Although I did figure them all out eventually, but yeah. But anyways, it's not, there's no boogeyman here. Every problem can be solved thereabouts. We can figure these things out. And when that one car works like an organ donor, it could save not just one other Prius, but it could save 10 other Priuses, right? And every one that we save and keep on the road for another year is another hybrid or electric vehicle on the road for that year. That took very little resources and carbon to essentially create at this point, right? Because if you're saying one of these Priuses, it's at 250,000 miles and it needs a new hybrid battery and it needs, brake work and a lot of the other stuff, the tune-up wasn't done on it, but you put all these things together and, especially if you're going to a dealership, you would be looking at a multi-$1,000 bill. And the car's only worth a couple $1,000, and that's when it's called financially totaled, which that's saying that it costs more to repair it than it's worth in dollars in our market. And we have a capitalist system, for better or worse, and that's what we have. Now, there's other measurements. There's other ways to measure value. And so you also have carbon or pollution reduction value. And so if you put a price on carbon, that's where you could start. If you put a price on releasing carbon, you can also put a price on saving carbon or preventing carbon or actually pulling carbon from the atmosphere, right? That's what carbon credits are, and that's what carbon offset credits are for manufacturers that, well, for anybody really that does some type of process, like we're talking for a business now, like commercial, that is carbon intensive. So if you're a transportation company, yes, that's carbon intensive. If you're, well, I won't go into all the other details, but yeah, so those are the places that may be interested or maybe by law may be required to either bring those emissions down or offset them. And by offsetting, it's more or less it's the same thing. And that's a different discussion about all of that. But yeah, the reason that they're doing that is because, like I said, they might have penalties that are kind of forcing them to do so. So yeah, if we just get more of these vehicles on the road, yeah, we get those emissions down faster. Oh yeah, and that, let's say that example I was giving with the Prius at 250,000, it needs new battery, needs this work, and it's become financially totaled. Well, that's, like I said, just because of its market value. And then they're also saying it's financially totaled because it costs thousands of dollars to fix this at this dealership. But if you said, well, hold on, well, Voltec gave me a quote using refurbished parts, and it's not thousands of dollars, and in fact, it's less than $1,000. And you said the car was worth $3,000, and you had a $3,800 repair bill before, and now it's been brought down to an $800 repair bill. Well, that kind of changes the picture, right? I mean, now you've gone from why would I spend $800 more to fix this vehicle than it's worth to, yeah, $800 to keep a vehicle on the road that's worth $3,000. Now, let's just say that it really did cost $3,000 to fix this $3,000 hybrid. Um, is it worth it? Well, it depends on who you're asking. If you're asking an economist, they'll tell you no. And if you're asking me, I'll say yes, or a climate scientist that is up to date on what I'm proposing, I guess. They would say yes, because by doing so, and especially if you're fixing it using used parts from a donor car, meaning already paid its carbon debt. You have a car already paid its carbon debt, and you're fixing it with parts that have already paid their carbon debt. You've essentially created, right? Because if that car was going to be taken off the road, which if it's like I just described, it probably would be. In other words, it was given a death sentence, and we exonerated it, right, and saved its life, and it cost no carbon or very little carbon. Like even if you used new parts to fix it, it's still worth it because the amount of carbon it saves in that year in operation is significant, right? And yeah, there's more I was going to say about that, but I'm looking at the time and saying, wow, it's almost 1:30, and last night I think I went to like 2 a.m. and I was looking at that time on there, and I was like, there's no way that's correct, and I was still on air like now. It's like there's no way it's 2 a.m. That's insane. I started at like 11. How has it been almost 3 hours? And yeah, it's like it's weird because every time I'm stumbling on here, it feels like an eternity. But when I go back and watch it, it doesn't look that bad. Or at least I just start talking, shooting out random other words, and then hopefully get back on track. So I guess it doesn't look as bad, but it feels like an eternity when I'm up here and when I'm stumbling. If I know I'm not live and I'm stumbling, it feels long. But then watching it really is like a second or two, but then at the same time, hours go by on here so quickly, and I'm like, I've already been on for 2.5 hours. What? Yeah, so somehow it feels really slow. At the same time, it goes by really fast. It's weird, which is why I'm practicing. That's why, I'm just saying it. You know what? We're just going right onto the internet with this stuff. Who cares? Well, I care, but it's an important message. So even though it's maybe not all clean and perfect and tidy yet, I think the message is important enough to just be, people should judge it based on those merits, right? Like, is this a good plan? And I will make it pretty, and I will make this a beautiful show. I promise you that. We'll have a lot of fun stuff. And it's not going to be what it is tonight, which is me talking for hours. This is practicing. And also, I am trying to get a message out here. And, but it'll get better as we go on. We have a lot of other segments of things that are planned that will be interesting. And, material like this, which I'm just literally going onto Google News, typing in electric vehicle, and pulling up whatever the first articles are that come up. And, that's what these were. I had a bunch of ones opened that I was going to discuss. But I did not tonight or last night because I just go on forever. to no end. Yep. My vape is basically out of e-juice. By the way, Michigan, we banned it. tangent cam for that one. Love cars. Oh, yeah. All right. Oh, yeah, this EV crate motor thing. All right. You know, there was... Which one? I talked about that one yesterday. Whew. Okay, the vape is done. The Irish are motoring greener and cleaner. Electric and hybrid vehicles now account for over 10% of Irish auto sales. That was important because, well, let's just look. Percent electric vehicles, U.S., right? $2.1%, 2018, according to Wikipedia. Yeah, not very much, right? And like I said, it's a moving target. You know, it's if 2.1% in 2018 is a smaller number than 2.1% in 2019. It's going to continue like that as we continue adding more people and more vehicles. And so that's why when this other article that was back here somewhere, it was the Irish, 10%. I said, yeah, that's a pretty big deal. So congratulations, Ireland. That's a good job. You know, that's basically it there. We could read details about it. Chevy Bolt EV at 3, GM electric pickup truck and UAW. Okay. Oh, this is electric car news. Yeah, okay. Toyota extends their warranties, blah, blah, blah. Electric car owners hard hit by massive California power shutdown. And yet, Mr. Musk promising battery and solar stations for people. Kind of like when he was talking about Puerto Rico. And I'm not criticizing him for that, by the way. I don't know how many... I don't know what exactly where they're at with that as far as how many power walls and they were able to send to Puerto Rico. Actually, that is a whole other part of EVA I haven't even got to yet, but that is that we can use these refurbished vehicles and these renewable energy power systems that we make, right, for very cheap. And these will be some of this stuff will be open source, I guess I should say. I can't say that all of it will be at this point because I don't know everything that we'll be doing in the future. But it is our goal to have most of this stuff. And obviously things that are crowdsourced, that is open source by nature. So, but it is our plan to be able to release a design to say, here's how you could build a solar power system using parts from a 2001 Toyota Prius inverter. Okay. So that's what we're doing, is putting together, like, actually getting these parts, already having them pulled out of vehicles and tested and categorized, labeled, and putting together packages and actually building a whole power system ourselves and selling that to people, making that available, or just releasing the designs for that and like the whole list of everything you need, where we could just sell a kit where you assemble it. Or if you want to go out in your country, wherever you're at, and go to the junkyard and take these parts off yourself and do it yourself. That is exactly what we're encouraging, actually. And because if people start doing that, that would mean that there will be all of a sudden all these very inexpensive renewable energy systems that are available to people. And that's opportunities for businesses, for entrepreneurs. And we're fine with that because, reducing pollution is our goal, right? And that's the goal of all of this stuff in the first place. So, but we also feel that, first of all, the countries that have benefited the most from petroleum do have the larger share of responsibility, and because we've benefited from burning all that petroleum, but it just so happens that the people that will be the most affected and the hardest hit by it are the people that have benefited the least from that. So it's important, we feel, in this, since we're conscious people, right? If you care about sustainability, you would probably consider yourself to be a conscious humanitarian. I do myself, and so I care about people as well as the environment. And thinking about that, I would want to ensure, or at least try to ensure, or do our best to ensure that the benefits of these technologies are distributed more fairly. The benefits and the costs of these technologies are distributed more fairly. And also, let's go another step further and say that, okay, then, so if you do believe climate science and you believe that man has an impact on the environment through carbon emissions, then and you are from a country that has benefited from that fuel, then you could say that you have a duty then to go help these people. And that is indeed one of the things that EVA will do. And we do that by, like how Mr. Musk was bringing power walls and solar panels to Puerto Rico after they were hit by a hurricane. And, the Bahamas has been destroyed. I was talking with some nonprofit organizations. I have been talking with some just through email and calling them and telling them about EVA and what I'm trying to do, and just doing some market research, because I'm new to the whole nonprofit thing, and I had no experience with disaster preparedness and relief. But that is an area that EVA will be focusing and doing things with, disaster preparedness and relief. And actually, I made a new term. I think it's a new term, and that is sustainable disaster preparedness and relief. And I think most people would say, well, when it comes to a disaster situation, Jordan, I'm not too concerned about biodegradable bandages when people are bleeding to death. Yes, neither am I. I'm not talking about that. What I'm talking about is actually some really incredible stuff that challenges issues that facing disaster preparedness and response, especially with carbon. It's crazy. If you want to talk about dirty power generation, well, there is a great article that I will talk about. I'll do a whole segment about it, about how backup generators are the dirtiest, most inefficient, systems, polluters we have, really, because they're just not designed. Your typical generator that you buy from Home Depot or Harbor Freight or something, depending on the brand, obviously but they're really only designed to run for 3 days. They're designed for about 200 run hours a year, I believe, or is it 20? I think it's 200. Yeah, 200 run hours a year. which means they're given an exemption. They don't have to have an emission control system. They don't have to have any of that stuff, nor do they have to have all the reliability stuff I was talking about for a passenger vehicle, or for a vehicle that goes on the highway that moves and it can injure people, right? So there's a difference there, but it's what we would like to do. What we will do is bring these vehicles and power systems to these places where they're needed the most, right? And yeah, the Bahamas has been hit really hard. And yeah, I was talking to some nonprofits before about Puerto Rico, a few months ago, and just asking, what's the current state of things there, as far as recovery, and what needs do people have? Like, what are areas, challenges that aren't being met? And what I found out just through some of this conversations and talking to the people from these organizations is that, long story short, there's a lot that EVA could do and that Voltec could do to help these disaster preparedness, response, and relief organizations. And how can I say that? Simply put, all of these relief organizations rely on vehicles and technology, and they use fuel, right, and energy and resources. And EVA makes all of those things more efficient, makes it so that you use less, which means you need less, or it means you can do more at the same amount, right? Back to triage. If I said before you only have enough blood to save 10 people and you have some new technology, maybe you could save 20 people's life with that same amount of blood. That's kind of where I'm going with this stuff, is that all of these relief efforts in the world, right? They have a certain amount of resources, a certain amount of fuel, a certain amount of medicine that they can use, and they have to select how to best use it. So if we can reduce the what's wasted and increase their efficiency, they would be able to help more people. That's the long and short of it. They would be able to help more people. Help the same amount of people using less, or help more people using the same amount. And it really, there's a bit of I don't know if poetic justice is the right word for that, but the idea of, the countries that cause global warming, okay, people from those countries then taking the waste products from things that were built to address global warming, repurposing them and bringing those to people in the countries that are being affected by global warming, and using that to help reverse, or not reverse, but slow down some of the effects of global warming. And really, in this case, with sustainable disaster response and preparedness, it's not about necessarily being green, although, like I mentioned, there is some troubling stuff when you really start digging into that, and that's a whole other episode. So, and that camera's almost out of battery. So, that's basically my timer at this point. But, we should, I think we should just, use these resources the best way possible, and using them to help people in countries that are so affected. And in this case, what I meant by sustainable disaster response, I'm not saying being green necessarily, but what I mean by sustainable is that, yes, if you brought a Tesla Powerwall down there to the Bahamas, okay, with the solar panel on it and an inverter, power inverter, and brought that to a town, they're going to have electricity for, the next 10 years or longer, right? And versus if you bring them to that town, a generator, and 50 gallons of gas, they have energy for a couple days, right? And even if they have all the fuel they need, well, like I said, most generators are only designed to run for about 3 days. If you have a Harbor Freight one, fire it up. Let's see how long it goes. I'll bet day 3 you're gonna have to shut it down. Something you're gonna have to change the oil. Something. It's gonna break. And running them for weeks on end with no emission controls, right? So people are breathing this toxic fumes. I mean, you want to talk about bad emissions. I mean, that's about as bad as it gets. And now, again, it's a disaster zone, right? So we don't necessarily care about little things like that. But this is much more than that, because if I said, well, I'm not going to bring them solar panels and batteries, I'm just going to bring them a generator that is 5 times as efficient, and it is 4 times as clean. In other words, it does not have bad fumes. It's quiet, right? It's not loud, and it uses 1/5 of the fuel. It's not a battery. It's not a solar system, right? It's not a carbon negative application. But what would that mean? That would mean that, like I said, however many people they could help before, now they could help 5 times as many. So, yeah, this is important. And it doesn't have to all be expensive. It doesn't have to all be boring. And I want people to be involved. I want people to get their hands dirty. I want you to go to a junkyard. I want you to do whatever you could do tomorrow to make some impact. Or if it's not in action today or tomorrow, then join us and start discussing things. And I guess I probably need to set up, I have Twitter and Facebook and all that, but I don't know, Reddit or something to have these discussions, or, a forum website. There is a website, evaelectricvehiclesforall.com, all one word. So I guess I could put a forum on there. But yeah, that's what I'm asking people to do is, we need help. If you like any of the stuff I've been talking about, if you own an electric vehicle, you drive a hybrid or electric vehicle, and you like the idea of having affordable service and repairs that the prices on, like a published price list for your state, for that vehicle and for those repairs, if you like that idea, if you like being able to buy battery packs that have been rebuilt for your hybrid, and not from Voltec necessarily. I'm not trying to open repair shops across the country. Quite honestly, I hope Voltec is the last repair shop that I own. I want other people to do that, and I'll give people the knowledge and resources that they need to do that. Why would I do that? Why would I help my competition? Well, I just told you I don't want to be wrenching on cars forever. Not to sound pompous, if that's the correct use of the word here, but my time is better spent at this point doing this and sharing my knowledge, because if you're a professor 100 years ago, you had to teach a class, right? Every year you taught that same class over and over and over, and hour after hour, the same lecture, right? Now with YouTube and with all this other technology, one time I can record this one time, or if it's showing you how to rebuild a Prius battery pack or something, I can record that one time. And this is a Creative Commons license, which means it's free for anybody to take and share. And all that we ask is that if you are using this, actually, if you make money doing it, fine. I don't have a problem with that. I want to save the environment, right? I mean, it's just that simple. And I know that's really oversimplifying it, because quite honestly, even if we stopped all carbon emissions tonight, there's a heck of a lot of destruction that's still happening and will happen. So, but we have to stop the destruction, right? You have to reduce it. We have to control it, damage control, and then start looking at how can we fix the damage, what we've damaged, because we can. We can bring back species. That technology, maybe it's not fully there yet, but it will be. That's why I care so deeply about the oceans and the destruction that's happening to them. It's so sad. And actually, it's not sad to me. It's infuriating to me because it's total madness when you really think about it, right? Think about this. Picture. I won't even do it. I won't pull it. I was going to pull up a picture of a nice mountains, right? Fields. You can picture that in your head, right? Maybe, let's just say the Rockies. You picture it somewhere like that. You got the snow on the top of the peaks, a beautiful place, and then you're down in all the green pine trees and everything, right? Well, in our system, that's not worth much. Like, the land itself is worth something, but all that stuff on top of it, all that greenery, all that trees, waterfalls, it's basically worth nothing in our system. Like, we don't really count that as anything. And in fact, what we count as something is we strip all that, we kill all the trees, dig up all that dirt, and to get, energy down in the ground. There was a really good cartoon you can find, or it's just one frame where it's got two guys. One guy is digging a hole in the ground, and the other guy's pointing, and he's saying, "I know there's an energy source down there. There's energy down there somewhere, right?" And meanwhile, behind them is this huge sun, like radiating all this sunlight, right? It's literally, there's just energy, literally money falling from the sky every day. Solar panels are just a collector. They just grab that stuff. That's it. And if you think about it that way, you'll realize that money is energy and energy is money. And I mean that literally. It really is. If you break it down, everything, you have materials and energy and time and labor. But really, at the root of everything is energy. So, why was I even saying all of that? I was talking about helping people in other countries that are being affected by climate disasters right now. And I was just telling people that if you can make a business out of something that you've learned from this channel, and that has a positive impact on the environment, right? Cleaning things up, reducing carbon, whatever it is, then I'm fine with that. And I would ask that you share this with other people and help people and help the planet. And that's really all we're asking, to use this information. And I hope people will contribute on all that. And because I am just one person, and I can't do it all. And that's why I need you to get involved. And maybe you don't have experience with this stuff. Maybe you're interested in it. Well, great. If you don't have any experience, then at least I don't have to untrain you. Right? And if you have experience, awesome. Yeah. So I need all types of people, not just mechanics, not just engineers. I mean, everybody. This is, I'm making these videos, and it will be condensed eventually. But, to explain this, because there's so many moving parts to what I'm talking about. And I'll show better videos and graphics that can link all these things together, so you can really get the picture. But yeah, hopefully day by day, every time I do one of these, I'm going to get a little bit better at explaining it. That's something else I figured out. If you have some business or some idea, I used to think, wow, why am I explaining it to this particular person? Like somebody that has literally no interest in electric vehicles. I might be wasting my time, right? Well, no, actually, every time I did that, it's practice. And every time I got a little bit better. I shortened it down maybe a bit, right? At this point, it's about 3 hours. But no, I could really condense things if I really wanted to. But I can't help but go off on tangents. So it is my own show. So I get to do that. Yeah, that's basically it. So being that it is 1:57 a.m., it's probably as good of a time as any to sign off. So thank you all for joining me this evening. And I hope that maybe you learned something. Maybe you didn't. Maybe you enjoyed yourself. Maybe you don't like me. Either way, I'm glad that you watched something with me in it. And, yeah, there will be more. There will be better stuff. And that's about the 50th time I've said that. So with that being said, the future of sustainability is DIY, and it's open source, and it is right now. And we don't need anybody, any government or company to do this for us. You've heard of DIY. I'm introducing a new one, DIO, D-I-O, do it ourselves. Yeah, we don't need anybody. We can do this ourselves, all right, as a team. This is a team effort. So let's make it happen, people. And, with all of that, I am going to be my own producer, and I'm going to switch this thing to the outro, which might be a little bit loud, but probably not. It should be about adjusted at this point with whatever my mic volume is. So, good night. Aloha.
Who's that? The mastermind. Who's that?